Test. Test.
Haven't seen it live yet.
Not yet?
Can you send me
It's been live for one. Give us 1 sec. Can you hear sound as well? Testing. Okay. 1 sec. Let me just set this. Okay, so it's already streaming live with the mic is on. Can you adjust the camera angle? So, which get the microphone for you?
欢迎使用索爱品牌蓝牙模式。
Oh.
You can have an introduction first, so that everybody sees it.
I mean, should I put it here or here?
Let's put it.
Okay. All right.
Yeah, so that's why I mean like actually helping.
Sorry. Okay, is there any way to remove echo? No? Yeah. Yeah, micro.
Because it's a Chinese remote. Y'all know how to speak Chinese?
I mean, the echo feels like, made me feel like I'm in karaoke. Okay. It's Is there any way to remove echo? No.
Let me try. Should be okay. This one. You try this?
This one?
No, like still, it's
Still go?
yeah.
You try again?
Oh, I think this is it.
This one?
Right.
This one better.
Yeah, much better, much better. Okay, cool. Thank you.
So in case,
Huh?
press this button. Just press.
I would say there is no case for use the echo, so
Okay.
yeah. Thank you. All right, guys. Thank you for coming here. I'm Gyuk from Dolabs, and we run the StarkNet Asia. Oh, before I start my talk, please enjoy the sandwiches and the beverages back there. We ordered a lot because of you guys, so please enjoy. And yeah, I'm Gyuk from Dolabs again. We run the StarkNet Asia. So we already did Stark Tokyo in this April, and we made Stark Seoul. After that, we made Stark Ho Chi Minh City, and we did Stark Korea last week. And now we are here, Stark Singapore. We made, many good memories, and I'm pretty sure you guys noticed that after the whole speak, we will take a group photo today again. So please be there. And yeah, we will have Star Kuala Lumpur during the ETH Kuala Lumpur. And we are talking about StarkNet events during DevConnect is Istanbul. So yeah, please join our Telegram group chat so that you will not gonna miss any like events or cool updates. Yeah. So I'm pretty sure that all of you used this StarkPass. StarkPass is a ticketing platform made by Dual Labs. Before I start saying why did we made it, let's just see the demo first. So, yep, this is the admin page. So, logged in as an admin and create events, put some details, set the dates, address, and ticket types. And for now, after that, you need to approved your events by the admin, which is Dual Labs, and we will activate your events. And after that, you can see the events on StarkPass. Right. And I'm pretty sure that all of you quite familiar from this step, right? Logged in via Google and put some details, and yep, you received your ticket. Cool. After that, what we did today is we logged in as a event organizer's account and scan QR for the verify. Yep. That's how it works. But when you submit here and when you get the tickets, what we really do is we hash it twice your data and store it on chain, which is StarkNet. And after that, in here, yeah, when we verify your tickets, we get the original data, which is we get the original data and hash it twice on a view function and verify it. Why did we make like this is I'm gonna tell you later. Okay. And yeah, like few years ago, not few years ago, like 2 years ago, I thought like blockchain has a huge potential, but still like it's too far to use in our daily life. For example, like my mother, I'm pretty sure that my mother cannot use Web3 applications, and I think the reason why is A, account, and B, transaction. So I thought, okay, it took like few more years for me to make a contract, and then Dual Labs comes out. So Dual Labs told me that they have a strong partnership with the offline entertainment company. They sell like a large amount of tickets per year, and that partner wants Dual Labs to make a ticket as NFT. So does it work? Door Labs did a kind of POC like a project. Door Labs sold NFT tickets. So this ticket is, I'm not sure who they are, but they did a concert, and the price of the ticket is around like 120 USD or 110 USD, around that. And they sell 300 tickets, and it's sold out less than 30 seconds, which is quite amazing. Furthermore, we saw the statistics about the users, and the result is here. So more than 75% was female, and most of them in their like 30s to 60s, which is not a typical crypto user at all. So I thought, okay, this could work. This maybe work. So, but here's the problem. In here, Door Labs forced to user to make their own wallets, and they're forced to buy the NFTs because it's a tickets. But I think after I saw the statistics of the users, I think like, okay, this will not gonna work in long term, definitely, because they are not a typical crypto users. So we struggled. Okay, then how can we make users to use our ticketing platform? The answer result was just remove the hard point. We removed the accounts and remove the transactions. So you guys all used the Stark Pass, but you guys didn't make any transaction, and you guys didn't connect wallets. That's how we did it. So under the hood, what we did is, like I said, we hash it twice, your data. I mean public data, and store it on chain. And we verify here using a view function by the plain data. So your QR has a plain data, which is public data. But why we did like this? We want to make users can mint NFT as a proof of attend. So like after these events, you guys can claim NFTs within a week or 2 weeks. So we are developing right now. We take once hashed data to trigger transaction, so that we can prevent leak of your public data. That's how it works, and that's why we made this program. And I believe early next year we're gonna test with real. This is a real event also. Okay, we're gonna test with offline entertainment companies, concert or musicals. So, yeah. And also there will be a Stark New York event on 21st. So if you guys go back to New York after Singapore, you guys definitely need to check about it. And yeah, it's pretty much it. And if you guys have any questions, concerns, please feel free to reach out via Telegram or Twitter. Or you guys can reach out to the Door Labs Twitter or email. Thank you. Questions? Oh. So
signature was it hashed publicly? I didn't get that part.
no. So okay. The question was which data we store on chain. That's a good point. So for now we store the ticket's unique ID, but after that we want to store maybe email ID like that. Yeah, not so it's not related with the blockchain. Yep.
If you store email and then the ticket, then let's say that means the ticket is unique to me, right? I'm not able to let's say trade it with other people.
Huh? What was that?
I mean, I thought it's an NFT, right? So let's say I want to resell the ticket, am I going to do so or I'm not allowed?
Oh, so before you mint the proof of attend, it's not an NFT. It's just data that's stored on chain. That's it.
But let's say if I were to, I mean, after that I can swap the sorry other people. Like, can I give away the
Sorry, after that what?
tickets? Can I give it to other people?
Oh, can you give tickets to another people? That's the question. I'll say yes, because you can capture your QR and just send it to another people, but you cannot send, yeah, and claim NFT rights because the QR is yours. So yeah. Yep.
I have one quick question now. You use sort of, so to claim an NFT, you need to use a QR code, right? Or something like this.
So why you need to do that is you need to log in our StarkPass website and just go to the previous event site and we will make a connect wallet and claim NFT button. That's all. Yep. All right. I think that's it. Again, thank you for coming, you guys. And our next talk is ZK-Link? Yeah, our next talk is ZK-Link, right? Vince from ZK-Link? Huh? Not here? Anyone from ZK-Link? Yeah? Oh, okay. Brian, sorry, can you start first? Sorry. Oh, yeah. I mean, yeah.
You've been looking for me for a while. Sorry for that. I was just sitting behind. Yeah. Okay.
Where's your?
I think it's inside. Yeah.
No,
Can you click the first
oh,
one?
yep. How can we make a presentation mode?
Yes.
Oh, just okay.
Yes, we just adjusted this
And
first.
there's no clickers. Sorry about that.
Okay, no problem, no problem. I just this feels like
And one more thing, you cannot go forward to this because of the camera is, yeah. Yeah,
the
yeah.
camera is here.
Yeah, yeah.
Perfect. Hi. Hello, everyone. How are you doing? This is Vince from ZK-Link. Very glad to be here at StarkNet Singapore to share the work and the progress that we have done at ZK-Link. I'm co-founder at ZK-Link. We're building a unified layer 3 on top of multiple ZK rollups, including StarkNet. So the talk of today is uniting the Ethereum layer 2 ecosystems with StarkNet, a rollup-centric future with ZK-Link. We are trying to build a secure, efficient, and unified trading execution layer that aggregates liquidity across multiple blockchains and rollups. The problems that we are trying to solve, liquidity fragmentation across rollups, this will, I think it has become quite obvious that there will be dozens of layer 1s and hundreds, even thousands of layer 2s rollups for application specific reasons. There will be maybe even more layer 3s for, because when an application has a very engaged and active community and a user community, they always will be facing the problem of the running high on cost and low in performance, and always want to have a dedicated blockchain or execution environment for their own application. They don't want to share the bandwidth, which is really limited on layer 1, and it will be pretty limited too on layer 2s. And also, by doing this, we're also simplifying the navigation among different blockchains and the layer 2s. Think about the way we use decentralized application nowadays. We often have to install a wallet for certain blockchain, layer 1 blockchain. And for some of the layer 2s, this is also currently the case. We have to install several wallets for several different applications, and this has been pain points for user experience. And users moving from one blockchain to another, one rollup to another, sometimes is complicated too. Especially for Web2 users, this type of user experience is not native, and it's hard for them to learn and to understand. And to enable mass adoption, we need to simplify user experience to the maximum. And by now abstracting the layer 2s and abstracting the complexities of underlying technology, users should not need to worry about, or you shouldn't care about like the technology. Even the technology itself is amazing. Think about it, when you use a smartphone, you don't really think about how the iOS is coded, right? So you don't think about that, you just know that it's secure and efficient, and it's good enough, and you really are just user-facing application, and you only care about the user experience and the features that you want. And also, there are security risks during interchain transactions, especially we have seen so many hacks already. The most recent one, I think there are hundreds of millions of dollars lost on bridges. And if this is will also be the case, because currently if you want to use layer 2 applications, the first step is to bridge. And instead of using official bridge means that you deposit to the StarkNet contract, and then the contract gives you the funds in the off-chain environment. Instead, I think a lot of users currently is still using a bridge that based on RFQ model or based on liquidity pools, or a lot of funds are controlled by the multi-sig. These types of bridges are extremely vulnerable. Even we were seeing the rising and implementation of next generation of bridges, which is a lot better in design, in security design. For example, layer 0, Axelar, these new types of bridges, they have separate the transaction verification and the judgment, which is the relay. Still, there will be additional security assumption coming with bridge. Second, there will be additional cost associated. Third, will be user unfriendly to use a bridge. Expensive and risky. So why wouldn't one want to just take out the component of bridge for some certain types of use cases and simplify user experience? There are some features that we provide to developers. ZK-Link is an infrastructure provider. Our focus is to provide a developer-friendly, ultimately user-friendly infra for trading applications. We provide the high-level APIs to developers that have intensive experience with financial product features, that knows how to run exchange properly in terms of liquidity management, in terms of asset listing, in terms of user acquisition and user operation. For a lot of the times, a lot of the teams that we have spoken with, have spoken to, they don't necessarily know, or most of them have relatively less experience with on-chain development, with smart contracts, with zero-knowledge proofs. They don't really need to take this heavy lift of learning from scratch how to build these sophisticated financial products. using the smart contract language, and if they want to go multi-chain or multi-layer, they actually need to learn multiple types of languages. This is heavily, I think this is developer unfriendly, and the development cost associated there can be saved with solutions, infrastructure providers like ZK-Link. So they just need to use APIs. High-level APIs means only few lines of code, and then you're good. Because we have done the hard part for them. We have developed the zero-knowledge circuits for them, specialized for their use case, and we provide also the access to liquidities from multiple rollups, multiple chains. We currently support a few different types of use cases, including central limit order books, this is similar to DYDX. But with the spot trading and perpetual contract trading enabled, at the same time, we have specific features that we have developed in our circuit to enable a feature-rich central limit order books. For example, unified accounts. For example, portfolio margins. These kind of new features will unlock doors for the application builders to acquire professional traders, acquire retail traders that wants to trade as the maximal of their capital, who want to maximize their capital efficiency and provides more possibilities and also more choices of trading opportunities. Also, we are doing this with a built-in account abstraction, so this will furtherly lower the entry barrier to onboard users. Though I'm not going to spend a lot of time on the settlement side because I think this is for layer 3s. I think the layer settlement on layer 2s today is not ideal, but with the maturity, with layer 2 ecosystem become more mature, we will see hundreds of applications being built in the same layer 2 and competing with maybe probably 100 plus TPS means that for a certain application, they will still have the problem of settlement speed. And also the finality time of the layer 2s of today are not good. I think ZK-Sync on their mainnet is 24 hours for security measures at the same time to save cost. But we expect this to be a lot faster on ZK rollups. With further implementation, this could go down to maybe 10 to 15 minutes, which is already very good from the perspective of layer 3, because our finality depends on the finality speed of layer 2s too. But our settlement on layer 2s will be instant. This is the protocol architecture. Here you can see that there are two separate deployments. There's ZK-Link rollup 1, ZK-Link rollup 2. Rollup 1 are for top 1, top 2. You can actually be just one application. You don't actually need several applications for one deployment. As long as this application has a lot of users, then they would really want to have their dedicated rollup environment. So, and they can customize the network collections. Currently, this is just the hybrid model, right? You have layer 1, layer 2s as the settlement layer. But going forward, I think we're going to see more and more deployment focused on layer 2s because this will reduce the cost. And under application 3, application 4, they are committing to a different deployments with a different network collection, with a different DA data availability solution. But what is important is that the different deployments of networks actually can share the cost of running the off-chain service. Means that they can use the same set of provers to generate a proof. They can share cost and lower the operational cost of the rollup. The types of networks currently support, including layer 1s, layer 2s, including ZK rollups and OP rollups. Ultimately, I think we'll go to ZK rollups because ZK rollups are the future of Ethereum at the very least, right? So because ZK rollups strictly derives security from Ethereum, while enable the settlement and the finality speed a lot faster than OP rollups. Although there are more builders right now and more liquidity right now on OP rollups, I still consider them to be transitional. So for some application builders today, they might have urgent needs of user acquisition and liquidity acquisition, so they might choose to still deploy on the OP rollups, so they can have a combination of both, right? But this will not change the fact that with the development of ZK rollups, application builders, especially for in our use cases, they would naturally want to move to ZK rollups because the requirement of security. When you manage large funds, when you are institutional trader, when you are a fund manager, you probably want to sleep very well if you like put in 20 million on the OP rollup with 7 days of finality time and no fraud proof implemented yet. If you think about it, it's pretty scary. The networks collection is just as I mentioned, right? So on this slide, you can see that we support the 3 types of implementation, but the actual direction that we're going is to become a pure layer 3 based on ZK rollup. So we'll become a Ethereum maximal ZK rollup centric layer 3 execution environments. And this is a very simple graphic showing how it works currently with deployment on layer 1 and layer 2. This is a hybrid model. And there is one additional component in this graphic that, compared with layer 2 deployments. This is with external light oracle network that helps to synchronize state roots on different chains, because the BNB chain cannot directly talk to Ethereum or StarkNet. So you need general messaging service to pass the state roots and to ensure the state roots that of chain, the validator service is sent to each of the chains are the same one. So you need to synchronize that. But if you only deploy on layer 2s, because all layer 2s talk to Ethereum, so you could do that indirectly with the Ethereum contract. You could send the state root to the layer 2s, and the layer 2s send that state root to Ethereum through the official bridge. And then the contract you deploy on Ethereum will synchronize the states and send back the confirmation to the layer 2 contract, and then the finality is achieved. This is a very simple explanation of the different types of DA solutions that we can support. So 2 factors you are playing with: security, or maximal security, and cost. Ethereum DA, as a DA, is very expensive. It is mostly expensive for obvious reasons. And there are cheaper solutions like Celestia. Won't be very cheap, but it will be cheaper than Ethereum. And there will be eigenlayer using the Ethereum nodes. And there will be cheaper solutions like ZK Porter, provided by ZK Sync, and also Volition. StarkNet has been talking about. There will be some, decentralized storage solutions like IPFS. You can use this as DA, right? So depending on your specific needs, there are different demands of security for different types of applications. For DeFi applications, especially for the ones that have high TVL, they naturally have demands for higher security. They have endless demands there, so they will naturally choose to go to Ethereum. But for NFT trading, for utility NFTs, for gaming, for social, they will have higher demands in terms of cost and lower demands of security, because even if you store the data somewhere like in IPFS, then users would still feel comfortable there. But what they really care is like the cost. And also you can do hybrids. There are some basic roles in the ZK-Link ecosystem. Similar to any other ZK rollup network, we will have our option service like the validator, sequencer, provers. We write the circuits, right? Code contributors write the circuits and write the protocol, and then we will involve community developers to contribute and have a DAO to govern the development of the network, which networks we're going to add to the collection, what features we're going to add for the next one. How to build on ZK-Link infrastructure? Very easy. Go to our website. Visit the website. There are detailed instructions of how to use our APIs, and there are examples of the APIs. And there's a playground. You can simply build a front end, very simple match engine. So you could build like a very simple spot trading decentralized order book. And if you have specific needs of certain features, for example, if you want to build a perpetual contract that has specific different design in funding rates, in liquidation, in the risk engine, then you probably want to talk to the core developers, and then we can design the circuits for your specific needs and with customization. And go deeper in that, we can optimize the circuits to lower the cost for you and improve the performance in certain areas, because we are playing with constraints, and there will always there's trade-off. When you have higher performance, you probably have like something that is less optimal. What do we have done recently? Okay, we launched Alpha Mainnet. There's one application, zkex.com. It is the first multi-chain central limit order book with spot, perp, unified account, portfolio margin on 10 minutes. Right now we're live on 6 layer 2s and 4 layer 1s. This month we'll go live on StarkNet. Mainnet, we're already live on StarkNet testnet for a while. And we have done several rounds of audits. The most recent ones we have done with ABDK. See, here are some of the recent updates. And also, something that I would like to mention is the asset recovery feature. This is actually the promise of adding ZK rollup or OP rollup, because data availability means that you can use the data stored on chain anytime at will. You can restore or reconstruct your layer 2 status. Any of you can do that. If you have like a basic knowledge of coding, you can use the program. You can download the data from the chains where you store your data and use that to reconstruct your layer 2 status, no matter what happens. So imagine a layer 2 team just disappeared. There's some disaster just happened. No one you can turn to. You can still do that yourself and permissionlessly. This is the promise of ZK rollup. And yeah, we have done this test in May this year. We have helped 60,000 users generated roughly 130K zero-knowledge proofs on our testnet environments and helped them to recover the funds from 7 different testnets. This is our journey with StarkNet. We have started writing Cairo 0 quite early. It was June last year. And we deployed the smart contract V0.1 on StarkNet testnet last year in August. And we began to upgrade the smart contract from Cairo 0 to Cairo 1 in this year. Yeah, Cairo 0, we have done that very early, but unfortunately, we have to do this again with Cairo 1. But yeah, now we're live on testnet with Cairo 1 contract. We have done the zero-knowledge verification contract with Cairo, and we have developed a very specific data structure to migrate our contract from Solidity to Cairo. There's some part missing, right? StarkNet is still developing very fast, and for our specific needs, we developed the bytes data structure to ease the migration. And this is, I think it is already open sourced last week or this week. Our devs is on this. We're very actively, we want to be more open source and want to contribute more to the developer community by sharing our work and anything that could be helpful to other Cairo developers. Yeah, this is an example of the data structure bytes. There's a lack of similar design in Cairo, posed challenges for transition for other Solidity developers to learn Cairo, and so I think our work will be beneficial for other Cairo developers. We're very happy to be part of the journey to help Cairo contracts become better and more usable, more developer friendly. Some details. Yeah, we want to provide an infrastructure solution that makes it easy for developers to build scalable and secure dApps across different Ethereum rollups. Because despite the fact that I personally really bullish and I like the Cairo community, well, we still believe that there will be other ZK rollup layer 2s that will have their own vibrant developer community, their own user community. So these different layer 2s going to form liquidity fragmentations, and you will need solutions for the liquidities to talk to each other and to be unified. And this will ultimately be contributing to greater innovation of user mass adoption. going forward, we are upgrading right now. Very soon we'll go on ZK-Link beta. The beta means that we'll have like this. I already explained how it works, right? ZK-Link being a layer 3, and we're posting proofs and transactions to layer 2s, ZK layer 2s, and talk to the Ethereum contract and get a confirmation from Ethereum contract, and then you synchronize the states across different layer 2s. And this is how we unify liquidity, and this is how we aggregate the liquidity. Yeah, so once again, we aim to enhance layer 2 ecosystem by unifying liquidity and by simplifying across ROB user experience. Our aim is to add value to each of the Ethereum layer 2 ecosystems and unite the Ethereum ecosystem by using ZK Snark, zero-knowledge proofs. Yeah, look forward to collaborating more with the Cairo community and with the wider range of developers. Thank you very much. Yeah, we're running this summer tour. The users can deposit the funds on these different layer 2s and experience different layer 2s at one stop. Thank you very much.
All right, our next talk is Brian from ZK-Lend. Yep. Good to go.
Perfect, thank you. Hello, hello. Hi, everyone. A quick introduction, I'm Brian, one of the co-founders of ZK-Lend. And yeah, I'll be talking about our protocol ZK-Lend. So just a little brief intro about myself. Well, this is the Evereye collection. If anyone is in the StarkNet ecosystem, you probably know that this is one of the more promising NFT project that's coming on board. So I'm one of the supporters as well. Before starting ZK-Lend, I was in the TradFi field for. Okay. Before the TradFi field, before starting DeFi project, I was in the TradFi field for some time. I was previously in Bloomberg, and then Standard Chartered doing investment banking, and then PE before starting this company. So what I hope to bring into the DeFi world, it's basically my experience with some of the institution and also basic risk management principle of the DeFi lending protocol. So for ZK-Lend, what we do is we have two product under one single roof. So we have basically on the right side, we have this is called the ZK-Lend. Previously, we called it Artemis, and then we are basically kind of rebranding it right now. So it's permissionless DeFi lending, pretty much similar to Aave Compound, where we do over collateralized lending. It's permissionless, decentralized, and we use ZK-Lend. We use the ZK technology on StarkNet to scale the transaction costs and also the speed of the lending experience. And on the right side, we have the ZK-Lend Institutional. And ZK-Lend Institutional is another institutional product where we combine the KYC and compliance requirement for institutions going into the pool. And basically, what we do is we target institutions for lending and borrowing. And that's similar to, for example, what we see in Aave Arc, what we see in Maple, TrueFi, etc. So the basic design is very simple. So and this is also a simplified diagram anyways. So for the ZK-Lend DeFi side, what we have is basically we have 5 different token pools right now. We have the 3 stable coins that we have, and also ETH and BTC on StarkNet. We are looking to add one more in the coming months. And essentially what we do is we try to build the public DeFi piece, the lending piece on layer 2, and then we also want to build a private instance of StarkNet, possibly on layer 3, or maybe another app chain application where this will be a KYC where all the users or institutions coming into the pool will have to go through a KYC process so that we don't get into issues of money laundering, CFT, and all these type of illicit funds transactions. And ultimately, basically why we want to build two products under the same roof. It's because we want to solve one equation, which is the capital efficiency of basically the whole DeFi system right now. Because what we see on the DeFi side is that right now the utilization for DeFi pool is actually very low. It's around 30 to, I would say 25 to 30% on a good day. And what it means is that 70% of the capital is not used. And that is by design, because when you have, for example, anything above 70, that's kind of where we sit for, let's say, our optimal utilization. Because in a bad day where there would be a lot of people trying to withdraw funds, you would want to discourage people from borrowing from the pool, so you increase the interest rate to very, very high. So then you always have maybe around, let's say, 20 to 30% of reserve in the pool. So which is why this is kind of deterring people to borrow the actual capacity of the pool provide. But that is not efficient, and that is not efficient, and that is okay. I'll try to be loud. I'm sorry, guys. And then on the institutional side, what we want to do is basically we have seen that there are a lot of borrowing demands, and for lending side not so much. So there's a basic good combinations between the two sides, where for DeFi side it's a good pool of lending capital, supply of capital, and for the institutional side it's a supply. They want the demand capital, and especially now that with the interest rate going to risk-free rate is 6%. So if you want to borrow, you're going at least low teens. So if you are able to borrow in DeFi, it actually makes sense for institutions coming in. So for our product, one side of it, for the DeFi side, we have actually launched in May this year. This is actually how the protocol looks like, and this is a screenshot taken, I would say, 4 or 5 days ago. And we have a TVL of roughly about 7 mil at the moment, and borrowing about 2 mil. So you can see that there's still about 5 mil of capital unused and across different currency at the moment. And so far, we have been quite blessed that our contract, the CKLend market contract, it's one of the most active or most actively used contract on StarkNet at the moment. We have an engagement of about 575 interactions, and I think over the board we have been around, I would say, the top 5 for the past 3 months. So looking at the DeFi side, the product design basically starts last year, and then in May we launched the mainnet alpha already. And what we are currently doing is we reworking some of the re-auditing our code, basically because what we have previously was in Cairo 0, and we have to re-audit it to Cairo 1. So for the past, I would say, 2-3 months, we have been working with Nethermind team on the re-auditing work, and we are ready to launch our mainnet version, I would say, towards the end of Q3, end of September time. And so that would be the mainnet with Cairo 1.0, and also TVL, and also the token campaigns. And where we're going with the institutional side is that this piece, this is where we're going. We want to still build out the CKLend institutional. And that one, the operational framework will get started, I would say, early Q1 next year. And we're going to start looking at 3 or 4 launch partners or service provider to basically provide liquidity for us, to become the lender or become the borrower. And the test set expected to be out around Q3 2024. And with further refinements, our mainnet is targeted to come out by end of next year. We feel that the institutional piece is definitely adding value to the whole DeFi ecosystem. The infrastructure is not exactly 100% complete at the moment, but we feel that in a year's time, there will be more clarity in terms of regulations, in terms of compliance, and also in terms of how RWA is being treated to help institutional borrowing. The formatting is all over the place at the moment, but we can still kind of guess it. So the TVL on StarkNet right now, it's about 164, and for DeFi, it's around 36. Since I would say I have been on stage in Ho Chi Minh talking about the TVL on StarkNet, and at the time it was around 60, and right now it's about 164, so about three times growth. But for DeFi, at the time it was 25. Now it's 36. So DeFi actually hasn't grown as quickly. And there are some reasons why DeFi is still being capped at the current stage. Some of these are the top projects on DeFi at the moment. There are some AMMs and us Lightning Protocol. I would say most of the construct of the DeFi protocol right now, it's still using DeFi 1.0. I think a lot of the protocol are still trying to experiment with StarkNet, trying to get familiar with the code itself, and then to build on top and add features that would actually help us to break through. Some of the current hurdles we're experiencing is that scalability. I think that's true for every protocol building on Ethereum, and high gas fees, slow transaction costs, and slow transaction speeds, and especially for DeFi for trading, that's a killer. UX UI, it's not straightforward to use, and there's also concerns over fund safety and fund control. Also, long-term sustainable liquidity, it's an issue. We see that there are a lot of incentive farmers and also mercenary capitals on StarkNet at the moment, and these are not sustainable, and they would just basically rotate between different L2s to get airdrops or to get engagements. And lastly, it's not capital efficient. Even for us, I would say the DeFi protocol that we are building for CKLand, the utilization rate is about 30%. There must be a way we can improve that, and there are far more lenders and borrowers. So we are looking at some ways to actually help to improve that. So for the scalability issues, I think a lot of protocols are starting to look to layer 2 as a solutions. So the emergence of layer 2, for example, StarkNet, it's one scaling solution that actually have helped improve the transaction speeds. Right now, you don't see it as very phenomenal at 6.8, but it's coming. There are some bumps and there are some bumps along the way in terms of achieving TPS for StarkNet, but ultimately we see that the team is still delivering, and they have been rolling back and then trying to resolve some of the issues they have, especially compared to 2 weeks ago where they have an issue with the network speed. I think that was also a stress test that actually helped to make the network more robust down the road. Another thing is optimization in terms of transaction costs. Right now, I would say the transaction cost is not high, for an average transaction is about 12 cents, but it can be definitely lower. And what we are foreseeing for StarkNet to basically roll out, it's two things. One, it's volition, basically choosing between two data availability mode between rollups and Validium, and also by about, I would say, early part of that next year, where we have the EIP 4844 for proto-dank sharding. That would actually work well with the L2, and that would essentially help to reduce the transaction cost by up to 90%. 90% meaning because the data cost for a transaction actually takes up about 90% of a transaction cost. That's why if you're able to reduce that amount, that should basically bring this 12 cents down to probably about 1 to 2 cents. And in terms of UX UI, there are a lot of different innovations being brought to the scene at the moment. So I would say being able to get users onto StarkNet, it's definitely one. So we have seen that, for example, Bravos, they have been helping with getting mobile wallets. So there are hardware signers and there are multi-sigs coming out. And even, same thing for Argent as well. Argent is coming out with their web wallets and also multi-sig wallets. So these are all ways to bring on new users to make the experience more friendly. And not to mention these two wallets, I'm sure a lot of you might have already known that account abstraction is a big thing for these type of smart contract wallets. So what they are enabling the wallets to do is a programmability in terms of payment. And that's going to be a big thing that would actually help to onboard some of the user experience from a EOA wallet where you have a private key and you lost a private key, you lost your wallet. This would be a lot better in terms of the user experience and the safety of the funds. And lastly, for the UX UI, we actually have focused a lot on shipping out educational content. So we feel that you won't be able to get users on board unless they feel comfortable and they feel educated about using the all the different protocol around the ecosystem. So we have done a lot of educational campaign around, for example, safety, around security, around how to know your transactions, and about how to use wallets. And we also have done meetups to basically cultivate a community for supporting different StarkNet projects, and as well as basically around the ecosystem, doing campaigns with, for example, Brick and Ducks Everywhere, so that people get used to using the wallet, get used to minting transactions, and being able to get familiarized with other protocol outside the DeFi ecosystem. So, and also in terms of UX UI experience, I think concern for security and fund security is one thing. So we have formed a number of partnerships, core partnerships for protocol safety. So we have done two rounds of audit, and they're with Netherminds and ABDK, and then for post-deployment security checks, we have Hibernative and chain analysis. Chain analysis is in progress, but Hibernative is helping us to monitor our market risk, and chain analysis is helping us to monitor our compliance rates. Basically, wallets that are tainted, then we will be able to screen those wallets out. And for pricing oracles, we use Pragma, and we have a partnership with ongoing partnership with Chainlink, so then when they comes onto StarkNet, we will also support that, and ultimately when they start with CCIP later on, we will also support their CCIP so that we can have the cross-chain experience, and also partnering with protocols like ZK-Link, so then we have the cross-chain ability as well. So these will be the two last slides. So for basically improving the overall experience with the protocol, we want to focus on new features that add incremental values to simplify the user experience. So one is, that is done already. We have launched our mobile version of the dApp, so then people can use the mobile wallets and the mobile dApp, so then you can borrow and lend on your mobile and at the fingertips. We are going to work on these three features. One is isolated markets, which is for short tail assets. We will be able to bring them on board and being able to contain a risk without having to contain the entire lending pool. Self-liquidating loan, basically what it means is, for example, when your wallets don't have enough liquidity in it, or you use all your wallets fundings to pledge it and for borrowing, so then you will be able to use your collateral to and also using multi-call and flash loans, and using those C tokens and repay all your loans in one go. And the third one will be a loan swap. Pretty much what it means is you will be able to swap your loan position from, let's say I have a USDC loan, I will be able to swap it into an ETH loan. And why would you want to do it? It's because, let's say you don't want to repay the loan, but you want to take position on, let's say you think that ETH would go down, let's say in a week or 2 weeks, then you want to convert it, so then you repay it in a lower amount. And vice versa, if you have ETH loan, you can convert it to USDC loan if you thought that ETH is going to be increasing in a month's time. And in terms of capital efficiency, this is what we want to build for the next year. We want to build customizable pools for institutions to go in. And then we also want to look at an interest rate order book. So we actually increase the capital efficiency for interest rate curve, so that we don't have the two-slope curve anymore, so that we actually would be able to use the entire capital pool rather than, for example, 30% to 50% of the pool. And RWA back loan, this one we are looking at different partners to actually help with RWA, basically asset-backed tokens. And what we want to do is basically for unsecured loan or undersecured loan for institutions that actually hold, for example, tokenized treasury products or tokenized securities in the real world. They will be able to use that as part of their collateral while they still maintain ownership of their real world assets. They are able to use that as some form of security for your lending for your borrowing on chain. So this is actually giving more security for unsecured lending. And last piece would be the floating to fixed swaps. Because we are doing a lot of floating rate loans, it makes sense for us to actually create a fixed loan structure so that we can let people to decide whether they want to hedge it or whether they want to basically bet against the floating rate. For example, let's say we see some of the DAI lending going from 2% all the way to, let's say, 40% in the past week. So if they want to lock it into a 5% loan, there would be different takers and providers. And one may take the view that it's going to be staying at around 2% to 5%. The other, it's going to have the view that it's going to be above 5%. So ultimately, you would have two sides providing the fixed rate and the floating rate, and that would create a credit derivative market that we can bolt onto the lending protocol. And that's basically what I want to talk about for this session. And thank you everyone for your attention. If you want to have a look at the protocol, you can go to our link and then launch the protocol, or just go app.zkland. You can find a lot of information on our Twitter, Discord. They're all on our websites anyways. So if you have any questions, I'm here. I'll be around, and I won't take up any more of your time. And then I think the next speaker is going to be Leron from StarkWare. So I think he will be sharing a lot more insights on some of the inner updates of StarkNet development. So I'm actually quite keen to listen to that as well. So thank you very much, and hope you all have a great evening.
Okay, thank you. Our next talk is Maran from StarkWare. Thank you. Did you upload it?
You don't upload it yet.
Can you upload it at Google Chrome? I mean Google Drive?
I did.
Oh, okay. Thank you. Yep. There you go.
Testing 1, 2, 3.
Charger
You'll connect now?
Real quick. Charger.
Charge the.
Speaker.
Ah, gotcha. Clicker. Oh, sorry. Wait, how do I click this to? Can everybody hear me? Yep, I can hear you. Okay, great. Testing 1, 2, 3. It's better now, right? Okay, I see a lot of familiar faces. I see a lot of new faces. So I want to make sure that tonight's talk is useful for everybody, which means that it probably will be less useful for the people who have been building the ecosystem for a year. But I hope that those people appreciate the value of making something that everybody can understand. So maybe whenever you ask people to raise their hands, nobody raises their hands. But let's assume everybody's equal with that. How many people are developers in general in the audience? A few, okay. How many have developed in Cairo? Okay, a lot of Cairo developers. How many have not developed in Cairo? And how many people is this your first like StarkNet event or side event or? Okay, there are enough people to see your first StarkNet event. Okay, so I'll keep the level of the content to you. There are a dozen hands are raised, so I assume there's like 3 dozen people, including the people who didn't raise their hands. I'll try and make it like 15 minutes and then like 5-10 minutes of questions. And again, it might be a bit of revision for others. I think it's worth it. So I am Liron. I'm the head of business development at StarkWare. It's also worth reiterating that this StarkWare is the like equity entity where there are developers and engineers and product managers who build software. Some of the software we build is for the StarkNet stack or the ecosystem and the infrastructure there. There's also a StarkNet Foundation. It's a separate entity. I'm coming from StarkWare. So I'll just want to talk about StarkNet, the technology, the roadmap, the ecosystem. The slides are a bit out of order. For the people who raise their hands and don't even know about StarkNet, are you familiar with like why ZK rollups are the future? Or should I explain about why ZK rollups are? We can work on that assumption. Okay, great. There's never a dumb question, really. So yeah, StarkNet. This is a slide we took. We got like to TPS close to 50 roughly 2 weeks ago. It's just showing the potential of the technology. The basic idea is to have Ethereum security with at least 100x the TPS of Ethereum. That's my words, at least, don't quote me. And at least 100x cheaper than Ethereum. Again, my numbers, don't quote me there. But I think that with the reasonable assumptions and engineering work, we should be able to get there. Jumping straight into features that exist. So account abstraction, who's like, so Ethereum has this EIP 4337, and that's basically having account abstraction not at the protocol level, but a layer on top of the protocol. The people who've this like the 15th StarkNet event, you're like, oh, I have to hear about account abstraction again. But to those who are new, it's a really valuable proposition. Basically, every single wallet on StarkNet is also a smart contract. It's, it's a deployed smart contract. So you have all the functionalities that you have in a smart contract you have in wallet by default at the protocol level. This basically, on a technical level, you have two stages. Whenever a transaction is submitted, you have a validation function and an execution function. Now, the validation function is completely up to you what logic you have there. You could have a traditional elliptic curve digital signature. You could have, like, some teams have developed the Face ID on your phone unlocking triggers a transaction. You could have session keys. You open up a key, you play a game for the next half an hour. Any transactions you submit from your address in that half an hour don't require signing because the validate function allowed that. It really unlocks, again, this is very cliche, but unlocks the blockchain to the wider world. So Web 2 users who don't want to manage private keys, they don't want to manage seed phrases, can now come and use StarkNet. This has nothing to do with being a ZK rollup technology, right? It's got to do with the design of the blockchain. Another important thing, this is like probably those sitting in the audience for your first StarkNet event, you're like, why Cairo? You hear this? This is skipped. Right, like why can't we just have Solidity contracts? And a lot of the other teams in the space who we highly respect have opted for more like what's called the ZK EVM. And there are 4 different types of ZK EVMs, and that's a whole lecture in and of itself, quite a technical lecture actually. There's this question, do you want to optimize for the existing EVM ecosystem, developers who can write in Solidity, or you want to come and take the other direction and say, let's write code that is optimized for the Stark proofs that we're generating. Some people, this is like a 45-minute discussion that I'm giving a 1-minute capture of. That's the core trade-off that we have here. We believe that having a domain-specific language like Cairo really helps you in terms of the performance of the network. And with Cairo, especially with Cairo 1, it's a very Rust-like language. And I highly encourage you to look at the resources online to try it yourself if you've never learned Cairo. I've done Starklings, I've done my own fair share of it. It is really it's a very high-level language. Unlike Cairo 0, the previous version, which gets like basically no assembly and like very detailed stuff about memory management, etc. So that's basically the thing with Cairo. Another thing worth mentioning is also the objective numbers in production. So we see it in production, not just like academic theory or tweets. Using Cairo, we're on StarkX at least, minting NFTs for 50 gas, which would cost like 60,000, 70,000 gas on layer 1, or DYDX trades on layer 1 would be 200,000 gas and like 500 gas on using layer 2. So we just think it's worth, like as a developer, it's worth a few weeks of investment to learn a language like Cairo and then be active in the ecosystem. Another point I'll say about Cairo is every developer in the StarkNet ecosystem has basically made an active decision to say, I'm learning Cairo in order to be part of the StarkNet ecosystem. In contrast, teams that have written Solidity code who just go to multi-chain and deploy on every EVM chain, they're not necessarily committed to that latest EVM chain they deployed on. They're like Solidity interested. So, and again, I'm not trashing that. I'm just saying that what you have with StarkNet is a vibrant ecosystem of like Cairo developers who are super committed to the ecosystem, which is a nice thing. What else can I share? Oh, the roadmap. This is probably worth speaking up for a bit. We are in mainnet alpha. We are in mainnet. We're submitting proofs. It's actually the 0.12.2 was out on mainnet last week. The big thing happening in the next few months, the first thing is volition. Who here does not know volition Validium? It's okay to put your hand up. One guy, okay. A few hands are coming up. I assume that means that there are, again, a dozen hands that are not up. So I will send them in on this, and others will forgive me. There are two things basically sent to Ethereum with StarkNet. You send the ZK proof, but the proof is not sufficient. In addition to the proof, you also need to know the state of the network. An analogy I like to use is you can tell your friend that x equals x, but separately you need to tell them what x equals 5. So too with us, like with DYDX trades on StarkX, you send a proof with all the transactions. You still need to know that Liron has $1 million USDC after all of those trades. So you send two things, the state update and the proof. The state update, you can send it all on chain, which means you have this massive Merkle tree of all the balances. Expensive gas, right? Because you're sending the state on chain. Another option is what's called Validium, which means you don't send the whole tree on chain, you send just the Merkle root of that tree. Now, if you send the Merkle root versus the whole tree, you have significant gas savings. I can talk about this for like 5 hours. Because even with the on-chain, if you do the roll-up mode, the first data availability mode where the whole tree's on-chain, you can do this clever thing where you only do the differences in the tree between proofs, right? But Validium, when you only have the root, you save all of that gas, and this has significant. It depends on the type of transaction and what you're doing. Like up to like 90% reductions in gas savings, in addition to like using the proofs already. So by using Volition instead of Validium instead of on-chain data, you save gas. Volition is just the name for choosing between Validium and rollup mode, because the chain will be able to support both, and you'll be able to choose which transactions on each one. So that I think Q4 October they're talking about testnet for that, and we think once there's a mainnet, there are a lot of like use cases where that becomes more and more affordable, which we're very excited for. And then there's a lot of stuff on the roadmap. Again, for those who are familiar, it's great. For those who are not familiar, it's not. Like fee markets. So most L2s to date just have a first in, first out sort of centralized sequencer, and you trust them. And the fee that they pay is based on a fixed formula. It's not based on congestion. This is critical for any decentralized network. And then you have Paymaster in version 0.15. Paymaster basically allows you to pay your transaction fees in any token that you like. So you have USDC or something, you pay in USDC, and you don't need the native token to pay your fees. Behind the scenes, it's taken care of. What's not on this roadmap? Like decentralized sequences are still a little while away. There's a lot, in order to make a performant and stable network, there are things you do first, like these sort of things. Cool. Let's see what else to talk about. I'm trying to see. There's this is all just like a shilling stock net, but I really want to keep it to interesting stuff. I'm using this just to talk about terminology. Ethereum, you know, I just want to like really make sure everybody in the room understands that. So StarkX is our app is a Starkware powered app chain service. So it's not like a decentralized open network. You call Starkware, the biz dev team, we like talk to each other, we sign a legal contract, we spin up an app chain for you. It's good in cases where that makes sense. There are other app chains on the StarkNet front, which we'll get to in a slide or two. Cairo, we talked about Sharp. This is also something worth talking to the people new to the group. Roughly speaking, it's the same amount of Ethereum gas to verify a proof, regardless of the size of the proof. I know I'm oversimplifying that, but given that the proofs, the computation in the proof is so big anyway, the marginal cost of verifying a proof, if more transactions are in it, are pretty negligible. So if I'm anyway submitting a proof, I'm very happy for you to add your own transactions to my proof, and that will reduce the gas costs per transaction. So we have the shared prover technology, which shares proofs between app chains and the public network. It's very, very cool technology. StarkNet we talked about. Recursion is something that happens right now it's off-chain. You basically verify proofs of verifications of proofs, etc. So you condense things more and saves on gas. And layer 3. Layer 3 is probably something we're talking about for a second. And then we'll go to questions. Okay, yeah. So basically, like, you imagine you have, not imagine, you have layer 1 Ethereum on the base. There's a smart contract there. They can verify stocks. And then on the public network, you have the shared prover. I just talked about this. So you'll have public Starknet, some other app chains using the same shared prover, sending a single proof to the verifier. And then you can basically have that same architecture. Yeah, all those people can benefit from Cairo, the volition data availability, account abstraction native to the protocol, etc. These are just the same points. Yeah, an app chain basically, I think you guys know the trade-offs pretty well. Like, you're not connected to the public network, so you don't have composability, but you have the control of the network yourself. But then, this wasn't really explaining layer 3. Layer 3 basically says, in addition to having layer 2, you can have a layer 3 app chain now, and there's a verifier contract in layer 2, and the proof gets submitted from layer 3 to layer 2. You could just do that exponentially. Why do you do that? You can reduce your gas costs, better UX, all the infrastructure that works with the public network should hopefully work for an app chain. So you can use the same wallets, the same API services that's spun up for their own app chain. It's a very elegant architecture. I think I'll leave it for questions. Anybody have questions or comments? Oh, sure.
About the papers, can we have something like we can sponsor the gas for the users? Like they don't have any tokens in their wallet.
Yep. So the question was whether you can sponsor gas for users, and if you have Paymaster, and the answer is yes. So for example, I want to buy an NFT, and the app says I will cover the gas cost of that NFT. Paymaster enables that. How? That's great. Yeah, yeah. Other stuff to tell you, I don't know. I've been. It's a very vibrant ecosystem. We would not put it this way. With Stark, the Starknet is too big now for to be fully dependent on Starkware. We're very reliant on people in the ecosystem like you, specific teams building important stuff. It's a decentralized network on the social layer, on the engineering layer, on the app layer, on many different layers, and it's something very exciting to watch. And I've sort of seen that transition from like 2 years ago to today. Yeah.
Yeah, I have a question about the last slide, and the topic that you said you can spawn multiple L3s
Yeah.
on top of L2. And here's the thing, the question is about more than 50% attack. It's sort of like you create multiple shards on L2, and therefore amount of nodes and users who hold nodes on L3 is kind of small. So if some malicious nodes will decide to attack, let's say over the capital, if there are like millions of L3s or whatever. So isn't that like a bottleneck of amount of L3s that you can possibly have?
Good. So I'll repeat the question for the video and for those who are couldn't hear. He asked if we have like hundreds of different L3s, aren't you fragmenting the security basically? If you need people to stake or just nodes to be running on each different app chain. Now, ignoring the question of whether each app chain is running decentralized or centralized, the security comes from the proof being submitted to L2 and eventually to L1. It's unlike optimistic rollups where there's economic security. Here there's cryptographic security. So you might have, assuming the proof actually reaches a layer where you sufficiently trust the security of that layer, that's where your security comes from. So like there's no withdrawal delays. For example, when you until you submit the proof, there's a withdrawal delay. Once the proof is there, you're good. So that is I think that answers your question. Meaning, as long as you're happy to be submitting proofs, your security comes the second that the proof comes. Yep. Components? Okay, the product managers were telling me like 2 weeks ago. So I need to check internally. It might be, unless somebody else knows. It should be a week or two away. I don't know, but I need to check. Other comments and stuff. Where to get started? You go to starknet.io. You follow the resources there. There's some really good community managed resources. I'm always scared to say names of individual resources because then I don't say other resources. So if you go to the starknet.io, there's a link to the documentation, to the Cairo book, StarkNet book. It was really good to start with that. Yeah. Any other questions or most of you are developers, right? Silence. Okay, cool. I will give it 10 more seconds for more questions. Otherwise, I'll stop. Yep. Oh, how many smart contracts are deployed on mainnet? So we know the answer to that. I think I'm roughly 2.3 million. I think if somebody using Cairo 1 or Cairo 0. There's a dashboard that I can pull up. I think there's people still using Cairo 0 for deployment until the regenesis happens. And I think it's roughly 2.3 million. Now that might include, I'll confirm the numbers after the talk. I don't want to say numbers that are wrong. So which specific change? The 4844 or? Oh. Interesting. Okay, so he's asking a very specific question about if the data structures on Ethereum move from like a Merkle to Merkle Patricia. Merkle to Merkle. I don't think I'm yeah. Tomasz is saying it's not going to make a difference. If anything, it's like any other smart contract that's already deployed. You're welcome to use those data structures, but it doesn't affect existing smart contracts. Like other stuff's worth mentioning. Even 4844 will make data availability costs significantly cheaper for L2s. It's good for optimistic rollups, for ZK rollups, for everybody. But I think like at the end of the day, this blockchain trilemma, getting scalability and high throughput, you're not going to have without layer 2s. Okay, another interesting question about optimizing the hardware. I assume for proof generation, you mean? I actually got asked this question today at a panel. There are teams working on that. There are low-hanging fruits. So we currently use these big finite fields. You can move to smaller finite fields with like 32 bits or 8 bits even, and that gives improvements. You can move to a different hash function, and that gives different improvements. And there's no point like optimizing the hardware for a specific hash function if like 6 months later you move to another one. So they're all in the research phase. Yep.
But inherently they are not quantum resistant. Starks are quantum resistant, but I don't think they are fully post-quantum because they don't rely on lattice cryptography or something like that, which will never be beaten by a quantum computer. So has StarkNet thought about
So the question was whether we've thought about if quantum computers come and able to crack certain hash functions and security. Yep.
Quantum resistant for now because we can assume that the quantum computers built for now may not crack it, but eventually we don't really know.
So when I speak to Eli Bentasson, our co-founder, about this, I ask him these questions. He says you can always just move to a different hash function that is quantum resistant or harder to crack by quantum computers, and that's orthogonal to to the protocol. Meaning it's a parameter that you choose in how you implement the Starks. Yeah, I don't think we're there yet. I think if there are quantum quantum computers manage to do this, we have bigger problems in the world, and I don't think that. Yeah, I think there are higher priority stuff like getting volition and decentralizing the sequencer. Yeah, cool. Great, we'll end there. Thank you.
Thank you, Liron. And our next talk is Edward. Yep. All right.
Testing. All right, so Liron gave an amazing presentation around what StarkNet is. And I think now it's the opportunity to basically speak about one of the products built on StarkNet with Cairo. And we've been building for pretty much 2 years now with Cairo 0.1 as well as Cairo 1.0. So yeah, happy to share more how we're approaching, the scalability of DeFi within the StarkNet ecosystem. So back in the day, we started working within Web3. We had a background of, working in Asia and kind of, tech scale-ups in Asia. And we understood that, the main issue was how do you scale DeFi for millions of users in the long term, right? And in order to do that, you needed additional tools that were not existing at the time. One of them is account abstraction, which obviously StarkNet has natively. And the other was, the power of ZK rollups to verify computation and scale beyond the TPS that we had at the time at the L1 level. And in general, why account abstraction matters is because for users who are living in mobile-first countries like Indonesia or Vietnam, you don't really want them to go through the pain of having to set up their own wallet, having to, onboard and bridge and so on, right? You want to make it very easy. So in the long run, you need this technology and you need to wrap, these wallets within smart contracts to actually enable, proper onboarding. And the other aspect was, okay, are we going to do AMM or order book? And in that thinking process, we quickly realized that Binance does 6 million TPS on a peak day. There's no way that we can get that TPS with smart contracts on chain right now. So we needed to come up with a new solution that will help us scale while benefiting from the proving that StarkNet gives to our solution. So ZKX is an omni-chain perpetual DEX. It's debuting with StarkNet L2 and harnesses ZK proofs and account abstraction to actually achieve linear growth of the TPS of the order book. And we're going to talk a bit more in detail about how technically we achieve that. But the key aspect here is that you want to service these users in a very simple way so they don't have to think in the long term that you're actually using crypto, right? You want to abstract away the entire experience. So last week we announced the ZKX app chain. And a lot of questions came our way from all directions on what the app chain is. So the app chain basically is an extension of StarkNet that allows to scale the computation functions of the exchange. So that is order book, funding rate, all the different algorithms that usually, within the on-chain environment is very difficult to scale. But in most cases until now, what you had were black boxes, right? Someone spins up an Amazon Web Services instance, they run it there, and no one knows what happens with the order book, right? They could be selling the order flow, they could be, front running you never know. Everyone has heard stories about BitMEX and so on. So we wanted to provide transparency, and transparency comes from having a ledger, from having some settlement that's happening on a blockchain. And for that, we're using our own internal substrate implementation. Some of you may have heard of Madara and what the amazing work they're doing with Rust-based stack within StarkNet. So we took a similar approach and tailored it to the order book and the functions of derivatives trading. So there's going to be its own block explorer where you can check what's happening with the order book and with all the accounts and balances of the traders. So with StarkNet, we're able to maintain self-custody of the user, while with the AppChain we enable, basically scalability and pretty much, gasless trading from the get-go. Now, there is an interesting aspect here, which is accounts are mirrored on the AppChain, but funds are retained on L2. And by mirroring the accounts on the AppChain, you can actually update the balances. And if the underlying network, at some point, is a little bit jammed or gas cost is higher because there's a lot of airdrop farmers or, any given situation, you still can, the validator still can post the updates, when the network is a little bit less congested. So it gives you a lot of flexibility to continue operating, 24/7, independently of any underlying conditions. So we're not going to go over this. It might be too much for today's talk. But basically, it summarizes the same structure we talked about. And why we think this is important, because in the future, you can let the community run the validators. You can implement some sort of staking mechanism for the token, so you secure and provide some economic incentive around running validators at the AppChain level. And we're also quite excited about the idea of recursive proofing and, attaching the substrate and Rust stack into, the sequencing and the ZK proofing in the future. So I think, there's a lot of design possibilities in the space of the AppChain. And we kind of able to then match the best of both worlds. And there is something very interesting here, which is dependence on oracles. So the entire ecosystem is depending on oracles, right? And the refresh rate of oracles is not that good. And they don't support always every asset or data feed that you want. And this is very critical for derivatives trading. You want to be super fast, in line with whatever any price change that's happening on centralized exchanges. And that's why the AppChain architecture allows us to have the validators pull in price feeds directly from any API, form a TWAP, and then we can list any asset that we want. So effectively, anything that is listed by a centralized exchange can be mirrored on-chain and traded in a decentralized way. And we think that's very important, and it's one of the main limitations that a lot of perpetual DEXs have out there, along with the lack of APIs, right? If they're purely smart contract based, most of the times they don't even have APIs for trading. So that leaves a lot of professional traders and bot traders that cannot use these exchanges. So I would say maybe here we can talk a little bit about the governance side and the ZKX account. So I'm not going to reveal a lot of alpha, but some of these things are going to be released on mainnet this month. And the ZKX account basically leverages account abstraction to allow users to have their own internal wallet through which they can use all of ZKX products. So that basically allows us to say, okay, you're a user on OKX. OKX supports withdrawals to StarkNet. So you can withdraw directly to your ZKX account and start trading, for example. And vice versa, you can actually send your money straight to your OKX account and immediately withdraw to your bank account. Or you can integrate fiat on-ramps and off-ramps. So it offers you a lot of flexibility. So we're quite excited, to be as well open sourcing a lot of these contracts over time and seeing, how more of these platforms become more autonomous and they can scale on their own by onboarding liquidity to StarkNet with their own account systems. And on the liquid governance, I think that is an interesting concept around derivatives trading and around tokens. And I always say that governance tokens are dead. They're really not that useful anymore, and they actually kind of don't serve the purpose for which they were created. And if you think about it, in the premise of the first wave of DeFi was, okay, we're going to release this governance token. You can use it to govern the DAO. You can use it to vote and make decisions. But you have to buy this token in the open market. So if you're a user of Uniswap, you have zero stake and zero say on what happens to the Uniswap treasury, even though you might be the top user, top 10 account on that particular AMM. So that's why we think it's very important that now that we're trying to build a new ecosystem, we actually provide new tools for better governance to the DAOs in the ecosystems. So liquid governance is what we're implementing for ZKX, but it obviously is going to be in Kaido, open source. We hope that everyone can take it and customize it in any way. but effectively it's a set of governance smart contracts that allows you to provide voting power given any set of triggers and interactions with the underlying protocol. So give you a simple example. I'm trading on an AMM like JDA Swap, providing liquidity on ZK Lend, right? And I've been using that system and that protocol for a long time. I should be able to have some voting power as long as I'm using the protocol and make decisions of what happens in the DAO. And that is something that, you know, right now with most protocols in DeFi is not possible. And we think it's very important. And it can be different roles. It can be the traders, the validators, it can be the liquidity providers. You know, everyone that actually has skin in the game should be able to participate and have some voting power. So I think I actually covered a lot of these topics. And I'm mindful of the time, and people must be hungry for dinner, so don't want to kill you. But we ran our testnet on StarkNet a few months ago, and we had a very interesting learning. So everyone in crypto creates these very complicated dashboards, trading terminals with all the bells and whistles, complex trading orders. And then when you actually talk to the users, you realize that, you know, they don't need all of that. They mostly don't even understand it, and it's actually making their trading experience worse. And you know, if we think in the long run, where in a world where people should not even know that they're using Web3, and that they should just be using the web, you actually don't want them to go through the pain of having to, you know, learn so much about how to use your tools and products. That's why we're approaching the trading experience in both ways. One is around basic trading, and one is around advanced. And each of these trading modes have their own user journey, their own funnel. Advanced traders need complex rewards algorithms. They need to know they're valued for the liquidity they provide, for the trading strategies they provide. So they don't really need a leaderboard. They don't really need, you know, like complex gamification. But for a simple user that's trying to come and trade on StarkNet, you know, from Vietnam or from Turkey, you might want to give them some quests, you know, some simple tools they understand to actually start using and taking, you know, their first baby steps around trading. And so this gamified aspect we think is very important in terms of, you know, achieving this onboarding experience. So DAO we have talked about, so I think that's okay. Most parameters of the smart contracts will be able to be delegated either to a sub-DAO or to any entity that wants to manage them. Right now, you know, let's say you have seen how, for example, Aave delegates its risk management to a certain other entities. So we think that giving the community the flexibility to choose who should manage, you know, the DAO is very important. So yeah, we talked about liquid governance, how the ZKX, you know, governance will work. So I think that's already covered. We call it digital shares. So basically, if you trade, if you stake the ZKX token, you get digital shares, and that equals to your ownership of the open source protocol. So, you know, happy to talk more about this in detail later on if you want. And yeah, a little bit of what we achieved. We did deploy on the StarkNet testnet a few months ago. Transaction time went through the roof. We kind of jammed a little bit the network. But still, you know, we had 58,000 accounts created, 180,000 positions opened, and about $1 billion in volume. So yeah, we're quite happy about that. And growth has been quite crazy. Some of you may have heard of the ZKX Yakuza, which is sort of this fictional world, cyberpunk world we've created with NFTs and quests and different, you know, characters. So that drove us to, you know, yeah, insane growth in the community. We currently have, you know, plenty of traders around all of these different countries in crypto, which, you know, Turkey, Nigeria, Korea, China, you name them, Indonesia, and so on. And they completed over 1 million quests on Zili, and that was kind of crazy. At the time, we were at the top along with Polygon and some of the biggest DAOs in the space. So we're quite happy, you know, how much the community has contributed and put, you know, themselves into ZKX. And yeah, roadmap, I'm not sure I should talk about that. And why did the team add this slide here? All right, so I think this is alpha, so I hope no one takes a picture. So We're doing our second audit as we speak with Nethermind, which I already seen some of our Nethermind friends around here. We're releasing our second testnet, a new season of the Yakuza. There's a product coming to mainnet in September, so stay tuned. In a few weeks' time, we have something coming to mainnet with Cairo 1.0. And yeah, we're looking at the mainnet launched very soon, as well as, you know, the full trading features being available to everyone. Thank you. I know it was a bit fast, but if anyone has any questions, feel free to ask. Yeah, yeah, all right.
I had you said about the oracles that you don't use the oracles. I'm not sure all the time, or is it like sometimes you use it, but because it's not listing all the data that is out there. So I have a question: how is validity of data that you get from some website or whatever is verified? Because oracles sort of they promise that it's correct, but what is about the key accent?
So basically the question is around oracles and how do you verify the data that you get directly through the app chain and make sure that it's actually real and accurate. So what we have found is that there's two problems with oracles. One is that they don't always call the original API. Sometimes they say, yeah, we refresh the price every second, but it's the same price. So that's one problem. The other is that the way they actually conform their TWAP can be arbitraged if you spot the pattern, because they might call an API every 30 minutes and another API every 10 minutes. So if you're able to detect those patterns, it actually provides an avenue for arbitrage. And we don't really want that to happen, right, in an exchange. So you need the validators to call in these different APIs, whether it's Binance, Coinbase, you know, Bybit, OKX, and so on, and be able to then conform the TWAP. So the process is the same as an oracle at the end of the day. And obviously you need some risk parameters in terms of, you know, any validator that will actually provide you a price that's, let's say, outside of the TWAP plus minus 5% or 10%. So that price should be rejected, right, and not be actually pulled on chain. Now, we're still working with Chainlink, we're still working with Redstone, with different oracles, so we still use them as a back check and as an actual, you know, security layer. But we want to make sure that the prices are refreshed as fast as possible. And obviously, if you have 5, 6, 7, 10, 20 sources, are exactly the same sources you're going to get, you know, through a Chainlink. It's just, you know, obviously Chainlink has a wider variety of validators initially, and that's probably, you know, their main advantage right now. But you can get faster refresh at a cheaper gas cost. Any questions, thoughts, doubts? Otherwise, you can catch me here, or our friend Naman over there with the ZKX t-shirt. You can also ask him any questions. We're going to be around. Thank you very much. Have a good evening.
Yeah, thank you guys. And our next talk is Chi from Nethermind, currently working at Voyager.
Hello, hello. Oh, I see some familiar faces. Hi, Gary. Can you guys hear me? Is it loud enough? I reckon we can. So we should make a start. Hi, everyone. Very nice to be here, and very nice to see like such a big crowd. And again, it's a pleasure to be here. And I see a couple of people pointing Voyager, Voyager. I'm going to explain to you what Voyager is in a bit. Right. Okay. I'm going to clear air. A couple of highs. Hi, everyone. My name is Chi Tran or Chi Tran Ang. I'm from Malaysia, and I'm making I took a 1-hour flight over to Singapore and this is a fantastic crowd. I'm so happy to see all of you here. I am a developer at Nethermind, and Nethermind does a couple of things in the ecosystem, in the Web3 ecosystem, and one of them is building an Explorer for StarkNet. And the name of the Explorer is called Voyager. So this is a quick explanation of what Voyager is. It has no relation to do with the exchange, right? I'm not going to talk about, where's my clicker? I'm not going to talk about all the other products that we built, because today the topic is going to be very specific on Voyager. So, yes, I'm a developer at Voyager Nethermind. Okay, this is my PFP. Yeah, cool. Next, oh, what I do? Oh shit, what I do? How do I go next? Do I click? Oh, okay. first up, I would like to introduce a couple of building blocks in a blockchain, right? A blockchain typically consists of blocks. You don't say because blocks chain and block. And within a block, we have transactions. And transactions are typically interaction to a contract, and contract have functions. And whenever there's a state change, whenever your contract wants to have a state change, normally the contract does to emit an event. And in the case of an L2, typically you have messages. So these are what I call the basic building blocks of blockchain, and the same is true for StarkNet. And these are the typical things that people are interested in when people want to understand or want to know about the state, about the information, about the data, or whatever you want in the blockchain. So these are the things that are important to you, right? So what do we normally use blockchain for? So I'm giving a simple use case, right? The first thing that you would normally do is that after I send funds to probably him over there, the first thing that I want to know is that I want to know if my transaction is successful or not. So in StarkNet, there is a concept of received on L2 and received accepted on L2 and accepted on L1. And in Voyager, I clearly have a small screenshot that describes this, that shows that we have this status. So after making a transaction, you're able to accurately see the status of the current transaction you're making, whether or not it has been finalized on L1 or it has been accepted on L2 and whatnot. The next thing that people are generally very interested in is to understand like how much are being transferred. For example, if I send ETH from A to B, I would like to know how much am I receiving or how much am I sending accurately. So the first thing that we do is that we normally type in we don't type in, we copy and paste the transaction hash to a block explorer, in this case the Voyager for StarkNet, and we will see like, okay, if the value is correct or not, if I'm sending the right amount of ETH. I normally do that when I try to, how can I say, withdraw from an exchange. I want to make sure that exchange is not making any bucks. The first thing I do is I copy and paste the transaction hash to a block explorer of interest, and I'll check the value is correct. So these are basic functions that a block explorer should have, and that Voyager has it. And finally, who is sending me money, or who am I sending money to? So the from and to parameters are super important, and these are the couple of basic things that, of course, a block explorer should have, and we are of course highlighting them. Okay, cool. I would like to bring you to a world of the ancient world, where life it's not as good as now, and life is without block explorers. My goal is to show you, is to try to attempt to let you know that we are taking block explorers for granted. So here it goes. So to understand how a transaction looks like without Explorer, right now we take Explorer for granted. We look at the nice UI, everything is nicely popular to us, it's nicely described to us. Without having Explorer, what we will need to do is that we will normally need to call the JSON RPC endpoint, and this is an example of one by calling get transaction receipt, passing in the hash as the parameter. This is the thing that we are going to get returned with. So as you can see, many of these are the hacks, like the contract address is hacks. The core data is it's basically the thing that you're calling the parameters that you're calling a contract. They are also in hacks and not too human readable. What I'm trying to make a point here is that it is not too clear, not easy for human to instantly understand, right? Sure, you can slowly copy and paste and decode this data, but sometimes if you are doing it, how can I say, you want to do it many times, you want to be fast, doing it manually may not be something that you would like to do, right? And now, for example, I'm calling a contract in the previous transaction, so I want to understand what the contract is doing, right? So there's another RPC endpoint on StarkNet, it's called getClassAdd. It will return me the ABI and bytecodes, and the constructor and bytecodes or whatever. So these ABIs are, how to say, templates for your contracts. So they have read-write function, but they do not contain the logic. So you only know like what function exists, what parameters you have to pass in the function, but you do not know exactly what the function does. So to do that in a block explorer, we urge people, Cairo devs, to verify his own contract on Explorer. So we will save the code for you, and users will not need to guess what the contract is doing. Users will only need to read the code to understand the logic of the Cairo contract they were interacting. So this exhibits the, how can I say, transparentness and permissionless attribute of a blockchain, of a public blockchain. As you can see, as we are trying to understand how a transaction is, what a transaction is doing, what the contract is doing, it is non-trivial already. Now imagine if you want to do something a bit more complex. For example, if I want to understand an ERC20 token, or if I want to analyze DeFi protocols. For example, if I want to plot charts, like what is the TVL over time for this LP pool. Imagine you have to do that using RPC calls. I'm pretty sure you will not be happy. Your mouse will not be happy, and your doctor, your psychology, whatever, will not be happy. Your mental doctor will not be happy. It's not good for sanity. So do not do that. And before I move on to the world of explorers, I would like to explain the motivation behind why Nethermind is building a explorer for StarkNet. So being an early supporter of StarkNet, Tomasz, our CEO here, huge supporter of StarkNet, and a personal believer of StarkNet, we decide that we know that we understand the importance of explorer in an ecosystem. And at that point of time, there weren't any team that was building Explorer for StarkNet. So Nethermind decided to take up the mantle to say that, hey, Explorer is very important and we will build one for this ecosystem. So it remains to today that Voyager is one of the explorers for StarkNet. And because StarkNet is different, it's non-EVM, that means that StarkNet we're not able to reuse some of the EVM explorers such as Etherscan, such as Block Scout, because they are fundamentally different because of the Cairo length versus EVM. They are not the same. So there is a need for someone to take up the responsibility to build Explorer. And therefore, Nethermind decides to build Voyager. So let's move on to the world with Block Explorer. It will look like this, very futuristic, very easy, everything's convenient, right? At a how can I say, flick of your thumb. And I clicked this very cute photo. Let's explore with Voyager. Okay, so let's look at a sample transaction of in Voyager. How does it look like? So first up, I would like to stress. Okay, so first up, this is how it looks like on Voyager. I took a screenshot of this transaction. It's not too important. I will slowly highlight the elements that are important for you. Okay, you can take a photo, but it's not too important, but you can. The first thing that you probably notice is that we have give some contract a name. So unlike in the transaction receipt where everything is a hash, Voyager takes up the responsibility in naming the contract address. So this one could be 0x something. To know that, you have to just hover it over to see the original contract address. But over here, for human readability and simplicity, we rename the contract to be SIP-swap. So right off the bat, you know that, hey, this transaction has something to do with a SIP-swap swap. And you know that this is has something to do with the if USDC, because we also label, we also give this pool address a name. So name tagging is something that's very important in the Block Explorer, because it helps in the UX user experience. So using it, you don't need to like remember. Oh, okay, 0xABC stands for X contract. 0xBCD stands for Y contract. We explorers, we save it on our DB. We give it to you. We help makes your life easier. And of course, it also shows how much token is being transferred. So right off the bat, you're able to clearly kind of understand, like, okay, this transaction is making a swap of how much USD to gain how much ETH at certain point of time, so on and so forth. So yeah, as compared to your RPC, this is I think it's much better. Of course, we also have some other things, such as we say when is this swap happening. Well, normally people don't care about when, but for example, if you are someone who wants to have a report your income on tax or something like that, the timestamp could be something important. And we also highlight who is interacting with the protocol. Oh, a quick highlight that these are the status that I mentioned before. Like over here, you can see that it's currently being accepted on L2, and after waiting for a couple of hours, it will eventually get finalized on L1. And if we were to scroll down for a bit, for those who would like to understand what the transaction is actually going through, we show the function that is being made in the transaction. So spoiler alert, StarkNet is native account abstraction, and it supports multi-call by default. So this transaction performs multiple function calls right off the box. So the first transaction will be the first function call will be approved. So we understand in the world of Uniswap in Ethereum, you first have to approve a token that so that the protocol can spend your token. So this is the first step that is going through now. SIPSwap is using a similar method as Uniswap, and you can see that we are approving the ETH token. And who is the spender? This is the spender, and this is the amount. And I know hex is something that is not something that we humans are familiar with. So if you were to click on the tab to the decimal tab, you'll be able to see in a decimal form. So that probably could be something that is very helpful for you. And again, this is a multi-call. So after you approve, you definitely want to perform a swap because that's why you approve in the first place, right? So again, we show by having the protocol itself has a nice name that sort of explicitly describe what it's doing. It's called swap exact token for token supporting fee on transfer token. So it means that you are swapping, I say USDC to ETH with some fee. Yeah, so this is what the function is doing. I did not look in the code, but from the name, you can sort of imply, right, what this function is going to do. And again, these are the details in the input parameter. So again, I stress that, oh wait, hang on, where was I? I stress that for those who are not good in hexadecimal like me, decimal is something that's already available. So you can see that you are swapping in this much of USDC and you are getting this much of ETH, right? And for those who are really into swaps and knows like how does a liquidity pool works, you will specify the routes. So basically these are like the number of hops you take for a swap to occur. In this case, it's only one route, and this is the pool that is involved. So this is that was pretty much what happens in the transaction. You are able to understand how much is being transferred. You are able to understand who you are interacting with. If you want to know more, you are able to understand the function that's being called in the transaction. Something that could be interesting to you, for those who really want to understand the state changes, you may want to visit the events tab, and this is how Voyager lists the events out. Events are basically emitted when a contract has state updates. It's not a must, but it's a good practice to do it. It helps in some DEX to write indexes, and it also helps for users to sort of understand what is going on in a pool, for example. I'm not going to describe each function, but I'm going to let you see that, again, the name here is being described, so you kind of know that these, okay, when a swap has happened, you know that some transfer event has occurred, some transaction has been executed, there's some swap-related events, and some token transferring events. So this requires a bit more of a specific protocol knowledge, so you kind of need to know SIPSwap to understand what is actually going on behind the scenes. So let's look at a swap contract. If I were to click in the swap address that I'm interacting with, immediately I will reach this page. This is a contract page. And the two things that I would like to highlight is the type, which Voyager has labeled as ERC20. To do that manually, you need to look at the ABI, understand that ERC20 will need a certain type of function, and classify it manually. But Voyager itself takes all the ABI, classified it, and stored in our DB. So at the moment you visit this page, we already know that it's ERC20, or ERC1155, or ERC721. So that means that this contract will definitely have some sort of like fungible token. And in the world of StarkNet, the logic of the code is being is being represented by a class. So for those who are interested, this is a class hash. You may click on it to look more detail as to who uses the logic of this class, and or what the ABI of the class looks like. And there are multiple tabs that I do not want to talk about today because there are so many tabs. But I would like to highlight some key tabs, such as we have the code tab that shows the contract API. And if this contract is verified, the contract code will be displayed here. So you're able to examine the logic of this pull from Voyager only if the contract is being verified. And of course, for people who want to interact with the contract very fast without having to write code, you may easily interact with the contract via Voyager. The read and write tab is here, and you're able to call your functions here. So, okay, the alternative to doing that is to write your own code. Use StarkNet.js or StarkNet.rs, depending on the language that you like. And then you connect to your wallet, and then you write some code to like, interact with the contract of interest. If you want to be quick, the Explorer is the way to do it. Click, 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 interact, and transaction send. I mentioned messaging. Messaging is something that is unique to layer 2s, and StarkNet is a layer 2. Messaging means that the information that's been transferred from layer 1 or layer 2 or layer 2 to layer 1 via an official bridge. So the common messages that was used is to bridge transaction. So for example, if you would like to transfer ETH from mainnet to StarkNet, you rely on messages, the messages on StarkNet, to receive your funds on StarkNet. And the reverse is true. Should you want to withdraw, you call an L2 to L1 message, and the mainnet will then receive that, hey, I received a message, everything checks out. You're then able to withdraw your funds from layer 1, which in this case, mainnet. So we have a dedicated page for this. Also name tags to show what are the contracts that are being involved in this message, and also the direction. So L2 to L1 from Stargate to whatever contract will typically mean that you are withdrawing funds from L1. So that means you are transferring from L2 to L1, and then you are taking it out on mainnet. The reverse is true. And if you were to wish to understand more about how the details of messages, you click into the hash, and this is how you look like. The payload, we have the payload, which is the message that's being sent, and this is very contract specific. It depends on the L1 contract or L2 or the L2 contract, depending on the direction that you're interacting with. So this one requires a bit of how can I say, a bit of a tedious work to understand what payload means. And finally, again, I stress that the message that we look at was a withdrawal message, and therefore Voyager knows that it's a bridge transaction and has nicely highlight that this is a bridge transaction. So we have the L1, L2 address that was involved, the if that has been withdrawn, and when was it withdrawn. So for those who would like to understand a bit more about the network status or the transaction fee or whatever, we have a couple of tabs here. We do have charts. So charts are a good way for us to visualize as to how the network's doing, or how the whatever that is involved. So I would encourage everyone to visit our analytics tab. This is an example that this is our one of the examples of our charts. And for those who find it useful, thank you. For those who like to have more charts, you feel that I would like to see this chart in Explorer, we are very, very happy to listen to you and also to write more charts. Because the idea is that should you want the chart, I'm pretty sure there are a lot more people who will need that chart. So it will be very, very beneficial for us to build a chart for you, not only because it helps the community, it also Voyager will also be, how can I say, be more helpful for you guys. And so all these are kind of manual, right? We talk about RPC, those are very manual. Exploring the Explorer is less manual, but I still say it's manual. So the question is, why do it manually when we have an API beta release? So I would like to stress that our API beta release is out now. We have a documentation for those who are interested. How do you apply for an early release? You just need to scan this QR code, or you go to voyager.online, and there's a top banner where there's a link, and you click onto it, and you have a Google form. So from there, you request your access, and we'll give you an access ASAP. Of course, the API is in beta release. So things might change, things might break, but we definitely value your feedback. Okay, a couple of people still scanning. Okay, we are good. And finally, I would like to thank everyone for listening, and I hope you enjoy. And any questions from the floor? Thank you. Any questions about Explorer? Oh, yes, this one. Okay, thank you for the question. The question was, what was the challenge when building an Explorer on StarkNet versus building Explorers on, for example, EVM chains, right? So that is a good question. A bit of a background for myself. I used to work at Etherscan, so I've been building Explorers for both ends. So I think I'm qualified to answer the question. So one of the main difference I face when building Explorer for StarkNet is the rapid changes of the protocol. So for example, for class, the concept of class did not exist before. So when they introduce the concept of class and there's the logics in the class, we kind of need to redo our architecture to accommodate for that, and fast, because StarkNet moves too fast. So we have to do it within like a couple of weeks to make sure that Voyager does not break. That's one of the challenges that we face. The second challenges is that there are L2 specific stuff or StarkNet specific stuff, such as messages, that are definitely not present on an L1. So we need to always think as to how users may need the data, or how this data can be displayed in a way that's beneficial for users to come up with a page and UX. Of course, things are not perfect. We value feedback, but we always try to dog feed our own product and try to see that, hey, this is not good enough, or this is good enough, so on and so forth. The third one, the native is kind of like a good point of StarkNet, but it's kind of like a different thing on StarkNet as well. We have the native account extraction. For those who are not familiar with, it means that all contracts are accounts, right? In the world of EVMs, they are all EOAs. So one transaction can only call one function. But in this case, it's multi-call by default, depending on the account they're using. So we need to kind of redesign the way to show the users, to highlight that the difference between the Etherscan you're used to and the StarkNet Explorer that you are now using. So the challenges, TLDR, I said a lot. Protocol changes, StarkNet specific features, and yeah, StarkNet specific features, and multi-call, which is and UIs that we need to think as to how we cater for the users. Hope that explains. Thank you. Another question here. The question was, what are the missing features compared to Etherscan? I have to admit that Etherscan is very much mature. They have been in the market for more than 5 years. 5 years or so. Voyager is a very new Explorer, because StarkNet is new, right? We have been here for like, I think, 1 or 2 years. Missing features. They do support a lot of DEX-related data. So there's a DEX tool where you click on it, you can view all Uniswap v2 and v3 data. That was built by me. Before I left. That is missing. There's a token approval tab, which was a bit not missing. But these are the features that we hope to one day bridge. We definitely want to prioritize them, but we do have other backlogs which are more urgent, like protocol changes is one of them. So these are the features. There are definitely a lot. If you were to scroll down, like definitely a lot, such as the ability to lock in, the ability to private name tag, the ability to verify contracts. There's a lot. There's a lot to play with. So, but our goal is to bridge the features with Etherscan as close as possible, or even to have more features than Etherscan, because StarkNet has StarkNet specific features. Yeah, that's our goal. Hope that explains. Oh, we have one more over here.
In terms of coverage of developers uploading like contracts into Voyager, how does that compare to, like proportionally, how does that compare to what's in Etherscan?
So the contract's more. So the question was more about contract verification. How does it compare to Etherscan? That's a very good question, to be honest. Etherscan supports Solidity and Viper verification, and Viper Solidity verification are kind of stable. Things haven't changed that much. But for Cairo, there's a Cairo 0, there's a Cairo 1, there's a Cairo 2. I know I was told to drop the Cairo 1 and 2 thing, but I still say it. Sorry, Starkware. Okay, this is a problem for us, because Cairo 0 was written in Python, and Cairo 1 onwards is written in Rust. So we kind of have to maintain two kind of compilers. the concept's always similar. You get the contract from the user, you compile it on your end, and you compare the bytecodes that has been submitted on chain. The difference is the number of compilers that we have to maintain. So in Cairo, there's always like a one compiler release every week or so, I reckon. So every 2 weeks, yeah, that's an expert here. So the maintenance is much higher, and which is why our Cairo 1 verifier is still in the progress, because we kind of finished that already, but then there's a breaking release in Scarp, so we kind of need to redo that part. So yeah, those are the challenges that we face. Thank you for the question. Any more? Don't be shy. You don't get to talk to people who work in both Explorers every day. Okay, I believe I'm clear, and thank you so much for your time and your attention. I hope you enjoyed the talk, and I hope you learned something. Thank you.
All right, so our next talk was Danilo from Kakao ZK VM, but he's running late, so his talk will start after 9 p.m. And until then, please feel free to network with other guys. Thank you. microphone, but the problem is microphone sounds like small.
It's fine.
Yeah, so you should keep this
Okay,
right in
okay.
front of your mind and like please say louder. And
Okay.
plus-
Can you at least introduce so that I
Sure,
don't
sure,
just
sure.
start?
I'm gonna do
Okay.
it. But also there is some echo.
It's fine.
Sorry about that.
Yeah, no worries.
So, your presentation is here, right? This one, right? All right, guys. Everyone. Sorry to interrupt. Our next speaker, Danilo, is here. I'm pretty sure you guys want to hear about Kakarot ZK VM. So please take a seat and listen. Thank you. It's hard.
The party is over.
I'm gonna say outside. So
Okay. Hello. So, yeah, I guess I came a bit late, but I'll get started. So, Kakarot is a ZK VM written in Cairo, and it's actually a project where we started last year, from around this time of the year. So first of all, what is a ZK EVM? Basically, a ZK EVM is a EVM that can be proved, and the idea of building a ZK EVM is that we can scale. Thank you. So everyone here must know StarkNet by now. There have been great talks. And so if you ask like, okay, you're from StarkNet there is already have a ZK VM. Why would you build a ZK EVM in Cairo when there's already a ZK VM? So one of the main points of building a ZK EVM is that the EVM ecosystem is very thriving. So there's developers and there's communities building a lot of toolings, and even now there's a lot of new projects being born for both developers and users on top of EVM. And in StarkNet, because it's a different language, a different structure, the development is a little bit slower. So, but there's a trade-off between a ZK VM and a ZK EVM is that the EVM was not done to be fast on ZK. So the trade-off is that we pay a little price on performance, but the positive side is that we benefit from the network effect from all the ecosystem that have been built since 2013 or 14. So just an overview of how Kakarot is. So Kakarot, the initial idea for Kakarot was to be a smart contract. The idea is that we would write the EVM in Cairo, and that can be deployed as a smart contract, or also it could also run off-chain. But our initial idea was, okay, we would build the Kakarot smart contract, the EVM smart contract, deploy on StarkNet, and then you would be able to interact with StarkNet using all the EVM tooling, and also interact between contracts, have interaction between contracts from Cairo contracts to EVM contracts. Everything on StarkNet. So this is basically the structure. The EVM transaction comes, it goes to the Kakarot Cairo contract, which is interpreted, is proven by the StarkNet OS, and then the state diff is pushed to L1. Right now we have a little different structure where we are also with the sequencers as Madara, Starkware sequencer, and even Lambda class sequencer. We have the ability to become an L2 or L3 or even an L4. So one of the biggest reasons why Kakarot was able to develop so fast is that thanks to the Starkware team, because when we started Kakarot, we didn't worry about ZK. We just focused on building the EVM using the Cairo language. That's the power of Cairo language. It abstracts a lot of the moon math aspect. Of course, we study, but right now we don't have any PhD in cryptography in our team. Right now we are relying mostly from what Starkware is building and benefiting from all the developments and the research they've been done for all this time. And a little bit about Kakarot history is that last year around this time, actually in October, there was a hackathon where 80 people from the StarkNet community came together and we stayed 1 week on IT Lisbon. And during that time, to prepare for the 80 hackers coming together, there was a list of projects where the community leaders would say, okay, like instead of just everyone coming and building their own project, like you have to propose a project and also you have to join one of the projects that were proposed. And Kakarot was one of those projects. So it was actually an idea from the Starkware exploration team, actually Abdel, and also a partnership with OnlyDoes because it was initially Kakarot was incubated fully from open source and from grants. Just a little bit more of story. The EVM contract is different from the Cairo contract address or the StarkNet contract address or the StarkNet address. And I remember that in the beginning we were in the hackathon and our goal was like, okay, we have developed for 4 days, but our goal is to be able to deploy a simple counter contract, pure bytecode, but a simple counter contract. And we were working on implementing all the opcodes that we needed, and we had to do this conversion between StarkNet address to EVM address, and then we added, okay, all the contracts on Kakarot will start with Abdel just because it was fun at the time. And the actual funny thing is that, okay, it's not like this anymore, but the actual funny thing is that during the hackathon, I think we had like 4 hours left, and we were debugging the contracts, and we had a bug where we couldn't figure out what it was. And then we were looking at the logs, and it's like, hey, wait a minute, like this contract is not starting with Abdel, what is happening? And then we were able to find the bug and actually fully deploy a counter contract for the hackathon. And now, what happened after the initial hackathon project is that Kakarot continued as an open source project until January this year, where we decided to incorporate. And it was basically Kakarot today is it's an emergence of the StarkNet ecosystem. Everyone here this picture was taken in the beginning of the year, so now we have a lot more contributors, a lot of new contributors. But you can see, like we had a community of 30 active developers, like contributing to one fully open source repository. Right now, Kakarot is incorporated, and we have now taking most of the core developments internally. We still have open source contributions, and since the incorporation, we were able to finalize the opcodes. We were able to implement the RPC, which is basically, you have the StarkNet sequencer, you have the Kakarot contract, and then you have the RPC, which will translate Ethereum API endpoints to StarkNet and API endpoints. And since July, since ETC, we have been testing our the Kakarot EVM with pre-alpha testers. And now we have 29, I think now it's around 40 or 50 developers already testing Kakarot. One of our goals, one of the things that we achieved, and one of our goals is to be able to integrate with all of the EVM toolings out of the box. And right now we have successfully integrated with MetaMask, Remix, Foundry, Ethers.js, and we plan on integrating with Hardhat, Vrim, Trufflebox, WogMe. And when I say out of the box is basically if you have a Kakarot RPC that currently you need to run locally, you can just add it on the tools, just like any other RPC, and it will work. You will be deploying an EVM contract on StarkNet. And it's a really interesting thing that's like when we first got the transactions going, like on Remix, we were like, okay, the transaction just went on Remix, and then we will go to StarkScan to check the transaction. And like you're validating the transaction with MetaMask, but then you would have to go to StarkScan and other EVM toolings to verify, because in the end, everything is it was a StarkNet transaction. So one of the things that we have been working on, now a little bit more than 3 weeks, this slide was not updated. A little bit for a month now, we have been migrating Cairo 0 to Cairo 1, because soon Cairo 0 will be deprecated. And we have been doing a lot of research on how to optimize, and you can check in our repo, Kakarot Super Saiyajins discussions. There are a few explorations that we've done before deciding which path to take. For example, we realized that in Cairo 1, now when you have a struct, the compiler automatically optimizes if you do a lot of struct changes, while in Cairo 0 before, you would have to copy everything in memory for every time you had to change. And there are also some other practices that you can check out the repo to see how you can implement in your own Cairo code base. These are some of the findings, which you can check on the repo. Right now, we have been focusing a lot on testing. Once the pre-alpha testers started to really test, we realized how, actually there's a lot of things, that was not checked before. And so the best thing for us was, okay, let's try to be compliant with the EF tests. Actually, we should have done this before, but we only realized about this 1 month ago. And now we are stress testing Kakarot, integrating with all the Ethereum Foundation's node tests, the Hive tests, so that we can be compliant with the test that was already generated by the community. Once again, here we're riding on the shoulder of like a lot of work that have been done previous to us. If you wanted to do all these tests ourselves or come up with all these tests ourselves, it would take a few months. But as the ecosystem is already big, like we can just, okay, there's so many tests already being implemented. We can just integrate it. Of course, there's some work we have to do to integrate with StarkNet, and now we've been improving Kakarot pretty fast. So if you're interested in, if anyone here is a Cairo developer or wants to become a Cairo developer, you're more than welcome to contribute to our repo. We have many good first issues. This has been in our, I would say, culture or motto since the beginning. Every workshop or every hacker house that we go, we prepare good first issues for Cairo developers. So even if you've never done Cairo, you can start contributing and learn Cairo through the process of contributing in open source. That's actually how I personally started learning Cairo, by contributing to Kakarot, and we try to keep this path open to any developer who wants to learn Cairo. So now the big question is, okay, when will you have testnet and when you have mainnet, and what could be the big differences from Kakarot to other ZK VMs, right? We expect to have testnet on this quarter, hopefully, and mainnet in the next year on Q2 or Q3. One of the things that we are expecting to have, and some of the changes that might happen as we go, is that right now there is a Lambda class is developing Cairo native, which technically would allow Kakarot, the Kakarot ZK VM to run in LLVM. And that would, it would not be provable, but we could parallelize the proving parallelize the proving, and we could potentially become as fast or not, or even faster than even optimistic rollups. So yes, thank you for your time. And if you want to follow us, here is our X, not Twitter anymore, and our Telegram. Any question? Okay, thank you.